Online YouTube studying channel. Once again, I'm Benumcha Vincent, and today's lesson is about current electricity. This topic can be covered both in O level and A level, but today the current electricity that we are going to look at is specifically for Senior 3 and Senior 4. So without wasting a lot of time, let's begin straight away. Branches of physics, branches of electricity. Be reminded that electricity can be categorized into two. We have what we call electrostatic electricity and current electricity. And I believe in future, in our subsequent editions, we shall look at electrostatics. Now, when we talk about current electrostatics, we are looking at the study, the form of energy that is as a result of charges that are at rest. Then when we talk about current electricity, we are looking at the study of flow of electrons. Let me just simplify it in this form. Look at the lightning conductor. How do you think it works? How do you think a lightning conductor works? We shall also look at what we call a Van der Graaf generator, that is in A level. All those ones work by the principle of electrostatics, charges that are at rest. I remember telling you some time back that when you get a pen and you rub it in your hair, then you bring it close to small pieces of paper, the papers will get attracted to it. That is all electrostatics. That is energy that is generated as a result of charges that are at rest. But today's topic is about current electricity. We are looking at the electrons flowing from one point to another. How is it possible for us to light a building? You connect wires. So meaning in the wires you expect current to flow from one point to another. Okay? You connect from the power source. So from the power source to maybe a certain appliance that you want. So that means there is transfer of electrons, of current from one point to another. That makes it to be current electricity. So therefore, current electricity is simply that energy, the form of energy that is produced by charges or by the flow of electrons. So when it comes to electrostatics, we are looking at the study of charges that are at rest. Remember, children, that charges can be both positive or can be either positive or negative. But we shall cover that when we are looking at electrostatics. So therefore, members, you need to put a distinction between current electricity and the electrostatics. So since our focus today is on current electricity, now let us look at sources of electrical energy. Where do we get? So members, let us look at sources of electrical energy. Remember when we are looking at different forms of energy, one of them was actually electrical energy. Now where do we get that energy, that electrical energy? One, we can get electrical energy from cells. When I talk about cells, I mean dry cells. For example, talk about dry cells. Do you know dry cells? Amanda, that is in our language. You can talk about solar cells. You can talk about accumulators. You can talk about, when I talk about accumulators, I mean the batteries, the so-called batteries, lead acid accumulators. So all those ones are sources of electrical energy because you can use them probably to light or to generate electricity. Then another source we have running water. Running water, use it to run turbines, and then you generate which kind of energy do you generate? Which kind of electricity do you generate? You generate what we call hydroelectricity. We also have sun, is also another source of electrical energy, and sun generates what we call solar electricity. Children, we also have what we call fossil fuels, we generate thermal electricity. We also have nuclear power that generates nuclear energy that generates nuclear power. Talk about maybe atomic bombs, formation of atomic bombs, or that is electrical power that is as a result of nuclear power. You can talk about hot rock in the earth. That's when you talk about eruptions. That is also electrical energy. So these are some of the sources of electrical energy. We can have as many as possible. So dear children, out of these cells, let us, because our focus, we are not going to focus so much on running water, sun, fossil fuels and others. Let us focus so much on cells. Let us look at what we call electric cells. Children, let us now look at electric cells. Remember we said that cells are sources of electrical energy. So let us look at them in details. What are these electric cells? Electric cells, in simple terms, are just cells that convert chemical energy to electrical energy. Their role is simply to convert chemical energy to electrical energy. Be reminded that actually these energy conversions, they are the ones which result into maybe production of sound, production of light, production of, energy changes. So therefore, electric cells, they simply convert chemical energy into electrical energy. And remember, electric cells are categorized into two major categories. One, we have what we call primary cells, and then two, we have what we call secondary cells. Now, with the primary cells, think about those cells which you use once, and you cannot recharge them. Once they are used up, you throw them away. Take an example of dry cells. Do you still remember dry cells, or do you know dry cells? Those are cells that belong to the category of primary cells. They cannot be recharged once they are used up. In other words, these are cells which produce current as a result of irreversible chemical change. When we talk about irreversible chemical change, we are talking about a change from chemical to electrical energy. So you can never reverse it. You can never reverse it. So therefore, such cells are categorized under primary cells. Then when you talk about secondary cells, those are cells which can be recharged once they are used up. Take an example of accumulators. Someone was telling me phone batteries. Look at the batteries we use at home. There are times they are called lead acid accumulators. Look at solar cells. You don't throw them away. You can reuse them once they are used up by charging them. So therefore, comrades, whenever they ask you to put a distinction between primary cells and secondary cells, put it in your mind that primary cells, they cannot be recharged. You use them once. After that, you throw them away. Then two, when they ask you talk about secondary cells, these ones can be recharged. Maybe in the future, I want you to research and you tell me why. At times, even when dry cells are used up at our homes, I normally see people putting them on sunshine. I normally see people putting them in water. Others, they squeeze them using their teeth. Then again, they put them back in radios. So we need to research about what is behind that. So probably maybe in the comment section, you will tell me why people in our villages do that. So let us look at primary cells and secondary cells in details. Okay, so primary cells, like I was explaining to you, these are cells in which current is produced as a result of irreversible chemical change. In chemistry, you will look at what we call irreversible chemical change. In other words, in a layman understanding, when we say reversible, you cannot take it back to its original form. Take an example of a paper and ash. Once it has turned into ash, you can never change ash back into paper. So these, in short, they cannot be recharged once the chemicals are exhausted or once it runs out. You cannot recharge. And then some of the examples include simple cells. We shall look at a simple cell. Many of you, I know you don't know a simple cell. What you know is actually what we call a Rank-Lanche cell. And a Rank-Lanche cell is categorized into two. Under Rank-Lanche cells, we have dry Rank-Lanche cell and wet Rank-Lanche cell. So I believe what you know also is what we call dry cell or dry Rank-Lanche cell. Note that primary cells, they supply a low voltage and low current. Just for example, you think how many dry cells do you need to operate a woofer or to operate a TV? or probably to operate any electrical appliance at home. How many dry cells do you need? So meaning that these simple cells or primary cells, they do not provide enough voltage to run a particular machine, or they provide low current. To those who remember, we used to have radio cassettes. I think they would use 6 dry cells. You would use it only for 2-3 days. So meaning that still the dry cells and other primary cells, they cannot be used to run a heavy task. Operation of maybe to operate a woofer or a heavy duty. This is not the best use. That's why we opt for secondary cells, like batteries. You use batteries, at least to light, maybe to operate a radio, to operate a woofer, something of that kind. So therefore, our focus in this, we are going to look at all these cells. We are going to begin with a simple cell. We go to a Lagrange cell, and then after we shall go to secondary cells. But to begin with, let me talk about a simple cell. Now, a simple cell, you can even make it at your home. You just get a tin, and then you fill it with dilute sulfuric acid. Then you get 2 rods. I will just call them electrodes. One should be copper, and then another one should be zinc. Now, copper is positive, it's an anode. Then whereas zinc is negative, it's cathode. So you get a bulb, and then you connect. For example, I wish the cameraman can show you. For a simple cell, we are going to get our tin. We fill it with the dilute sulfuric acid. Then we insert 2 rods. One is a copper plate, which is positive. And then another one is a zinc plate, which is negative. So we are going to join these 2 using a wire. Maybe we can put a bulb here. This is a negative, this is a positive. Remember, electrons flow from negative to positive. These are electrons. Then current flows from positive to negative. This is current. Now, when you connect these 2, and remember they are dipped in dilute sulfuric acid, so this is dilute sulfuric acid. So we join it like this. Remember, we have said it consists of a copper rod, which is positive. It has a zinc rod, which is negative. You dip them in dilute sulfuric acid. So electrons, these are called electrons. They are rods. They are connected using a connecting wire. You can even pass there a bulb if you want. You can connect a bulb. But then they will ask you a simple question. That, because I don't want to go into details of it, because you will cover it in electrolysis, that is chemistry. But they will ask you what happens. Explain or state what happens when the electrodes are connected together. One of the observations is that once you connect it like this, the bulb will light. It will give off light. After some time, it will go off. The bulb will give off light for some time. Then after it will go off. Maybe someone can also ask you to explain why it goes off. Now children, one of the disadvantages of using this simple cell is this. One, remember I told you that zinc reacts more with this than copper. So once you connect them together, there are reactions that take place between zinc and our dilute sulfuric acid. At the end of it all, hydrogen bubbles will be formed on the copper plate. Hydrogen bubbles will be formed on the copper plate. These hydrogen bubbles that are formed, they tend to insulate the copper plate. So meaning that the copper plate will no longer be in touch with dilute sulfuric acid. The moment copper plate is not in touch with dilute sulfuric acid, that means the circuit will not be complete. Therefore, no current will again pass through the bulb. Therefore, the bulb will go off. So you say the bulb will give off light. After some time, it goes off. Why? Because due to these reactions, hydrogen bubbles are formed on the copper plate, and these hydrogen bubbles, they tend to insulate the copper plate. Hence, it is no longer in contact with dilute sulfuric acid. Therefore, the circuit is incomplete. Okay? So that is one of the disadvantages, because every other time you connect the copper rod to the zinc plate, hydrogen bubbles are formed here. And the moment hydrogen bubbles are formed, that means this one is out. So therefore, that's why simple cells are not reliable, and that's why they are no longer available, because they were replaced with what we call dry cells. So one of the disadvantages of using this is that hydrogen bubbles are formed here, and that defect is called polarization. Actually, one of the defects of using this, or the defects of using a simple cell, is one of the defects about the defects of a simple cell. Why is it so disadvantageous? Why can't you rely on it? Besides supplying low voltage and low current, it has two important defects. One, I told it, is polarization. Polarization is when hydrogen bubbles are formed on the copper plate. So when they are formed there, they insulate it. So they stop further flow of current through the cell. Therefore, the bulb or anything will go off that you have connected there. The second and important defect is called local action. So local action is when you have used impure zinc. You may use zinc which is not pure. What do I mean that impure zinc? You find that zinc is mixed up with iron, maybe and carbon and some other elements. So these carbon and other elements, they will react very fast with the dilute sulfuric acid. And instead of hydrogen bubbles forming on the copper plate, this time around they will form tiny local cells on the zinc plate. They will also insulate the zinc plate from the electrolyte. At the end of it all, no current will be formed. But there are some important things that you must note. One is that electrons, they flow from negative to positive. In other words, electrons flow from zinc to copper. That is one. Two, current flows from copper to zinc. Current flows from positive to negative. Another important point to note, when the copper electrode, when the copper rod is connected to zinc rod through the bulb will give off light for some time. But then it will go off. And I remember telling you it will go off because the bubbles of hydrogen gas which are formed around the copper plate, they block further flow of current from the cell. And therefore, the bulb automatically will go off. So, defects of a simple cell. One, we have said that a simple cell, it produces small current and stops working after a very short period of time. I told you that. And it stops working after a short period of time because of these defects. One is called polarization. And I've told you that polarization is simply the formation of hydrogen bubbles along the copper plate. So these hydrogen bubbles formed, they insulate the copper plate from dilute sulfuric acid. Therefore, this will block the flow of current, meaning that current will no longer be flowing through the circuit. And at the end of it all, the bulb will go off. Or, that's why I told you, it is unreliable. But there are some ways on how we can minimize this defect. How can we minimize it? We are not stopping it, but at least we try to minimize it. One, we add what we call a depolarizing agent which at times we call a depolarizer. We add it into dilute sulfuric acid, and we can add there potassium dichromate, you can add there manganese 4 oxide. So those depolarizers, what they do, they will oxidize the hydrogen formed into water. So meaning that there will be no more production of hydrogen. Whichever hydrogen is produced will be oxidized into water. So meaning that the challenge of hydrogen shall be at least eliminated. Then 2, you brush the copper rod quite regularly. Because remember, once the hydrogen bubbles are formed there, it creates, or the hydrogen bubbles create stains. So if you don't brush them regularly, that means it won't work. So we are saying you can use a depolarizing agent or you brush the copper plate regularly. So let's look at what we call local action. Okay, so now let's look at local action, and like here we are saying that it is due to some reaction between the impurities in zinc, e.g. those impurities can be iron, carbon, and they which react with the acid, resulting into the formation of hydrogen bubbles on the zinc plate, or which result into formation of tiny local cells onto the zinc plate, which tends to insulate the zinc plate from the electrolyte. How can we minimize this problem? We can minimize it by rubbing zinc, and that zinc must be clean. You rub it with a small globule of mercury. You just rub it with mercury. You create what we call a zinc amalgamate, or you amalgamate zinc. So this prevents contact of impurities with electrolyte, meaning that even if zinc has some impurities, they will not get into contact, or they will not react with the dilute sulfuric acid. Then 2, you clean zinc with concentrated sulfuric acid. You clean zinc with, and then lastly, ensure that you have used a pure zinc. Zinc that is free from impurities. So dear children, those are some of the ways of how we can minimize those 2 challenges in a simple cell. But the fact remains that the simple cell provides, supplies little current or small current and small voltage. Do not forget to subscribe to my YouTube channel, which is Homeline Studying YouTube channel. My telephone numbers are 07597468 and 0787553787. Ensure that you comment, you hit the comment section in case there is something that is not clear. I will find it there and then we discuss. And also every Tuesday and Thursday, we always have Zoom meetings in the evening for O level and A level respectively. Ensure to WhatsApp me and I send you a link if you are interested. I remain Defects, and I meet you in the second edition of this topic. See you. Goodbye.